Good morning, ladies and gentlemen. Dear Martin, thank you very much for your nice introduction. As Martin already announced, I will speak, my first talk will take into account the main environmental impacts of tunnel construction. Ladies and gentlemen, tunneling in Europe is completely other field than mining. Even if we use the same methodologies, we are treated completely different. The reason for that is, I would say, a mistake in the law by the European Union. I like to call it a mistake, but the lawyers say, okay, we have to work on that. And we are working on that, I would say, more than 10 years now. And as Martin mentioned already, the Brenner base tunnel, which is 3 tubes, 57 kilometers each, we have about 17 million mineral resources which we deposit. And this is, and when I was the head of this project, I said it's ridiculous what we are doing. We are filling up valleys. Austria is a small country now, and we have to fill up valleys. We have to bring people out of the valleys to give them new houses, because we have to deposit our materials. So you see, there's a main environmental impact of tunneling just by one of these projects, and we have several of them for the moment. Just Austria is building about 200 kilometers of tunnel right now, and we need lots of deposits where we bring the materials to. And this situation has to be changed. I think this is an international situation or in all Europe, maybe also in Argentina. And we have to change this situation, because it's a little bit ridiculous to use primary resources, not in the industry, but fill up valleys or deposit it. Tunnel excavation material in its most complete and highly quality utilization illustrates an important contribution for a sustainable economic system by means of efficiency and also effectivity. The utilization affects both the local and regional environment, but also the global environment. Of course, we could try to reuse most of the material on site, but it's not always possible. But what we should try to do is we should try to reuse the materials for the industry as close as possible, or on the construction side, and thus substitute other primary resources which we have to dig for the mining, for producing, for example, the concrete on the construction side. Construction engineering, by the way, is the most important sector with regard to economy and ecology. So it has a substantial part on the GDP of the countries. Its contribution to the global warming potential is about 1/3. It requires about 40% of the global energy, and it contributes to the waste stream with about 50%. So these are quite high numbers. It's just the construction industry. What I would like to show you is some important worldwide developments, and I start with the population. You see, 750, we were not even 1 billion, now we are more than 6. Water use, we have the numbers from the 19th to the year of 2000. You see a multiplication of several factors in the water use. Let's see the urban population. What we see is, in all Europe, maybe also here in South America, that the urban population raises up and leaves the countrysides, which ends up in, let's say, really difficult situations in the cities, because let's say, we have pretty small cities. Our biggest city is Vienna with about 1.8 million, but gets, let's say, 100,000 people every year, and the infrastructure is not prepared for that. And all the other cities have the same problem. Paper consumption is just one other example, or restaurants. The number of restaurants is raising up a lot, as you see, worldwide. Transport, motor vehicles, the number starts in 1950, goes to the year of 2000. You see the rise in these motor vehicles. They all need energy, of course. They all need primary resources. Or, for example, the communication, the telephones, the mobiles. Everybody has a mobile nowadays. International tourism has started dramatically, and thus needs a lot of energy. This ends up in a global warming potential. All of these development, what we see worldwide, so the CO2, let's say, production in the last years is really raising up, and we had a goal to reach a certain limit of this CO2. For example, Austria doesn't meet these requirements, so we have to change something in the country to fulfill the requirements which were legally fixed. For the moment, we are completely out of the CO2 production, for example. The same for nitrogen, the same for other materials. I just brought 3 slides with me. You see, all these numbers are raising up a lot. So we have to change something if we would like to go down with these climate change issues. We tried to figure out who on this world, on this globe, is the main consumer for energy. What you see is the energy consumption per capita. And you see Northern America is the most, takes, let's say, almost the double from Europe. I also put in Latin America. You see, you are not using too much energy compared to Northern America or to the other parts of this world. So this ends up in completely different CO2 productions, just to mention one of these global warming potential factors. Let's see how is the global contribution of the construction sector to the environment. I already mentioned 1/3 of the CO2 emissions come from the construction industry. 40% of the energy production, energy consumption on the world is going to the construction industry. 25% of the water consumption is going to the construction industry. 40% of the resources consumption is going to the construction industry, and 60% of the electricity consumption is also going to the construction industry. So if we change something in the construction industry, we can really save resources. That's what I wanted to show with this slide. And then the other factor, what we see is 80% of the world's population will live in cities in 2030. Because we see a mainstream, the farmers, to be a farmer, for example, in Europe is not a very attractive job. So everybody thinks living in the city is much, much better than to be on the countryside. As I said, and this will need a lot of, let's say, underground structures in these cities, producing a lot of, or needing a lot of mineral resources. 40% of the world's population need new buildings, by the way, because I don't know if you follow what is going on in Europe. Austria is mainly concerned of these, let's say, streams which are coming up from northern Africa through Austria. Most of them would like to go to Germany, but you know, the border is closed now, so they end up, many of them end up in Austria because they are not allowed to go to Germany. We have no buildings for them. So our parking garages are full of people. So we have no parking garages in many cities because full of people because they are sleeping there. There is no housing available for the moment. So we need buildings, we need subways, we need sewers and all of that. We have to think on the processes in life cycles. First of all, we have primary resources, that's clear. What do we do? Out of these primary resources, we are very used to produce our materials, and these materials then go to the construction site. Okay, to the tunnel. If we are not reusing the material directly on the construction site, we will need extra lorries which are coming from the mining sites, bringing the new fresh material. Or if we don't use this material on the construction site, we have to deposit. We have to go kilometers with our excavated material, producing every kilometer CO2 and all the other materials. Okay, when we operate the tunnel, you know, the most clients would like to see 100 years of lifetime of a tunnel, very popular now. The Brenner base has 150. There are coming up projects with 200 years of lifetime. I don't know how to check that, but it is written in the contract. Lifetime must be at least 100 years. And then we have to think on the recycling. What do we do when the houses, when the tunnels are reaching the end of lifetime. By the way, most of the tunnels have to be repaired after 30 years. That's what we see, that's the reality. But however, the contract says 100 years. So when we design and build these tunnels, we should think on how to recycle these products which we used in the houses and also in the tunnels. And hopefully only, let's say, a very small stream then is going at the end to the deposit. The recycling has to, let's say, be developed in a way that we can use all these materials again for the construction industry. You may say there's lots of materials available, mineral resources. I mean, there are mineral resources, lots available on the world. Yeah, but the kilometer what you can, let's say, transport them is very limited. For example, Vienna has the problem, as we have a lack of mineral resources in Austria, we are now buying our mineral resources from Czech Republic. But the distance gets quite high. So at the end, the colleagues who are living in the houses have to pay more for renting the house because it was much more expensive to build the house because the mineral resource came from the other nation even. So this we should consider when design and build our things. I just wanted to show it in another way. So first we have raw materials, then we manufacture them, we distribute them, we use them, and we dispose them. And then we, at the same time, should think on the environmental impacts. Is it possible to renew the materials which we use in the construction industry? We should think on the choice of the technology for extracting the raw material. I say if we build a tunnel by a tunnel boring machine, for example, there is nothing which we bring to the materials, so why should this material be a waste? If we do drill and blast, I mean, we are very comparable with the mining industry, so why should this material which we dig out be a waste? When we manufacture and distribute, how will this product get to the customers? We should think on that. We should make this calculation of CO2 production by construction. How much energy will the product use? What happens when the product is finished then? And how will it be disposed? Are there disposal areas available, by the way? In small countries, the disposal areas are not, let's say, there are not so many where the people who are living there are allowed to go there. I mean, it's just for the moment a matter of legal, let's say, ranges that the one is higher than the other, and even if the population is not in the opinion that this is not a good idea to make a deposit there, the legal requirement says, yeah, it doesn't matter what the population said, we need that land and therefore we take it. But how long can we do that in that way? I just brought a slide with me to figure out a little bit that we are running out of mineral resources. You see, in the 1960s, we had lots of mineable gravel reserves. It's a picture of Europe. And then in 1994, many things changed because we got the environmental impact law. It changed in a way that every project, every tunnel project, had to go through an environmental impact study. So, for example, we are, besides this Brenner-based tunnel, we are now building two quite big tunnels. The one is the Semmering, which has 27-kilometer length, 2 tubes. The other is the Coram tunnel, which has 33-kilometer, also 2 tubes. And we had to do an environmental impact study for that. But the situation changed dramatically. Before 1994, we had nothing considered in that way. Nobody of a tunnel engineer, when I was a student, we didn't hear anything about that. We were the tunnel engineers and we said, okay, the tunnel has to be built there and that's it. And all the others who claimed something, we ignored more or less before 1994. In 1994, the situation changed. Okay, environmental impact study has to be done, and we have to have the checkers from this side. So there's one ethologue who is watching what are the birds doing. There's one from the fishery. There's one for the plants. There's one for the trees, and many more. At the Semmering-based tunnel, I mean, the situation collapsed a bit because there were 56 experts and only 10 technicians. The rest came from the environmental, let's say, part. And you can imagine that it's quite hard to bring a project through if you have, let's say, 40 experts on the environmental side and just, let's say, about 10 working on rock mechanics and tunneling issues. So we have to bring it back a bit so that the technicians and the environmental impact guys are, let's say, half and half. For the moment, the situation is still the other side round. So it takes many, many years to bring a project through. Our, let's say, what we learned from that is if a project takes about, let's say, 10 years for realization in the construction stage, it takes about 10 years for the preparation. So this is the change because of this fact. But however, I think we learned to live with these environmental things and we have to consider them. The situation is better than before 1994, but we have to be careful that these guys from the environmental impact side, they don't, let's say, hinder us so that we cannot build anything in the future. This is the other side. I think we have to find a way that both aspects are 50-50 in the weight. You see, this chart was done to see how the mineable gravel reserves are reduced. And they were presented to the European Union. And this brought then, let's say, an initiative to Europe, which I will talk a little bit later on. Because of this environmental law, the groundwater conservation got much more important, the landscape conservation, the construction areas which were already built, everything was considered here. And so the part where you have this gravel spoil standing is we still use minerals, of course, and thus the part for the mineable gravel resources in future gets smaller and smaller and smaller. And the question is, what is in 2050 or even after that, if we go ahead like we did? Of course, to use the mineral resources coming out from a tunnel has several aspects to be considered. The one is the volume. I mean, if I have a very short tunnel, let's say 100 meters long, it will not be worth to set up a processing unit and all the things what a mine needs. The tunnel length and the bore size have an influence. But the Brenner Base, as I said, the Brenner Base tunnel, which has this 57 kilometer times 3 tubes, 17 million cubic meter of excavated material, is worth to think about it. Let's set up a processing unit like a mine has. Then the material use in the tunnel or the available industry. Let's have a look. Where is the industry who could use these mineable or these resources which we get out from the tunnel? Because 17 million cubic meter, what I mentioned, is the production of Austria. All mining industry is doing on these resources. So this tunnel produces the same than all the mines are producing, you see. This has to be considered. Geology, of course. Not all the geology will be able to be reduced. We have to get specifications for the use. What is the minimum requirement on this material which we get out? The tunnelers are most time used to speak about UCS, uniaxial compressive strength. They are speaking about a friction angle and a cohesion and a Young's modulus. All of this is out of interest for the industry who is using these materials. The industry, what we learned, is very interested in chemical and mineralogical, let's say, consumptions. But we, for years, did not even check that in a preliminary stage. So we have to change that so that we can get in contact very early with the industry and say, okay, we are producing these minerals and we are producing these chemical consumptions, what comes out of the tunnel. Then the location, of course, is important. The distance to receive, let's say, the industry. If this distance is too far, then it will not be worth from the economical point of view to transport it there. So on the one hand side, we have a supply which comes out of the tunnel, which we can, let's say, deliver, which we could sell. I say we could sell because, of course, all the industry knows that we have to pay to get rid of the waste. Tunnel excavation material is a waste by law, so we have to pay for getting rid of this waste. All the industry knows that. So the industry tells us for the moment, okay, how much do you pay if we take your mineral resources? A little bit ridiculous situation. On the other side, we have the demand, of course. We have a population who needs a specific demand, and I already mentioned the transport distance is of interest. The goal which we have is that we are used on construction sites to set up processing units, like the mining industry has. And if the tunnel is too small or is too short, whatever it is, we have to find a partner from the minerals industry to give them the material to make a product out of it, so that the disposal site, this part, gets to zero. This is the major goal. For example, in Vienna, we are digging metros. We are in a clay situation. The mines around Vienna, they are producing bricks out of that material. So what we checked is the chemical and the mineralogical consumption of the material coming out from the metro in Vienna. What we saw is it fits 100% to that requirement of the mining industry, who is digging out the same material in open pits and is producing the bricks out of it. And so why not to deliver the material from the metro in Vienna directly to these mining companies? But it's forbidden. For the moment, it's legally forbidden. And if we do that, we have to pay a lot of money to the mining companies. They have big fun with us. The other situation is, and that's the easier way, we deposit it. So we bring this material out of Vienna and fill up or make deposits around Vienna. But truly spoken, I would say this is let's call it a secondary resource that people in 30 years know, okay, the bricks material lies down there on this deposit because they digged it out from the metro. Legal situation in Europe was a little bit funny at that time, let's say 2017. In 30 years, people will say that. And now let's mine these secondary resources because it's the best material. Why not? So our big goal must be to get the disposal sites down to zero. So for miner, very clear, what should we learn? We should learn how to crush it, how to wash it, how to grade it directly on construction site, if possible, and then bring it to the industry. And please, let's change the law in this way. It cannot be so hard to change a law because it was written by, let's say, the generation of us that we have this law, because the law is existing in Europe since 2002. So it must be existing lawyers who wrote this law. And we have to, what we don't do in European projects is we don't, let's say there is no must to do these global warming potential studies. And I have a lot of other parameters written down there, the ozone depletion, the primary energy demand, the eutrophication. All these are parameters which the construction industry for the moment is not used to. So the environmental impact study, which is required, does not include studies on that. But if we would start with these studies, we would immediately see, okay, we are producing so much CO2, for example. But there are many other parameters which we should take into account. We did 3 studies in a European project where we checked a project which is situated in the French side of Switzerland, I think it is Le Farret. They produce 135,000 tons of excavated material. Then Nantes is a powerhouse project in Switzerland. They produce 4.6 million tons. And then a very famous project, Lyon-Turin, Michel will know that perfectly, a very long tunnel like the Brenner Base Tunnel, but connecting France with Italy. producing about 28 million tons of excavation material. And these scenarios, what we studied were, worst case, we bring all to landfill, 100%. Actual case, what are they thinking on? Or what are they doing? Because non-détrans is already finished, I would say, from the excavation point of view. Or in the best case, we are really using this material and not landfilling it. And then we figured out what is the CO2 production, just to get into one parameter. If we do that with Le Farret, you see we have about 5 kilograms CO2 per ton of mineral resources which we get out. In the actual case, because Le Farret really reused the material in the best way, I would say, they saved CO2. The same for the non-détrans. If we do landfilling with all the material, we have 8 kilograms of CO2 per ton. In the maximum case, if we could reuse this material, because it's in the middle of the Alps, powerhouses are always situated in a perfect, let's say, rock mechanics situation. So if we reuse all of that, then we would save a lot of CO2. The problem is non-détrans is situated in the middle of the Alps and the industry is not sitting up there. This is the problem. Lyon-Turin, 100% landfill, would cause also about 8 kilograms per ton. In the maximum use would be down to about 1 kilograms per ton. If we do construction works, it must be clear that we are influencing the environment. I don't want to run through all these points which are shown on this slide, but of course we are limiting the mobility of the animals because of our tracks which we are setting up. We are reducing the habitat areas because of the construction. We will cause vibrations, we will cause warming, because the locomotives, but also the cars, they are bringing a warming in that area where they are going. We are also bringing noise to the landscape. We are changing the electromagnetic fields. We are changing the groundwater levels. All these things we should now really start to consider. We like to call it, and what? Because everybody will say, yeah, when you change the environment in such a way, why do you build something? Why do you start to build something? And what we have to do now is we should say, okay, what happens in this area if we build nothing? Compared to the situation from the environmental point of view also, what happens if we build something? And we should do a prognosis for the next 10, 15, 20, 50 years, if possible. And then show the environmental guys, okay, what happens if we don't do something? So let's take a city. If we don't build any, let's say, metros, is the situation then really better? Or can we, let's say, we know we are bringing noise to the city in that area because we build a metro, but isn't it equivalent, let's say, important because we are now having fast infrastructure and no traffic jams and all of that? And this is the discussion which we have and which we will have much more in future. Just to be clear, yes, we are changing the environment a lot. This must be clear to all of us, and we have. And these, just to mention, these were the points which we didn't consider before 1994, because we said we build a route, and everybody should be happy if we build a tunnel here or there. Martin and myself, we have a boss, I had a boss in Salzburg who lives in a generation who was not used to this. And he was following me often in meetings for the Brenner Base Tunnel, where we started to live what I show here. We, from the technical point of view, say, okay, we need transport, we need technology, but the others, which are coming in, they come with the requirements from the environment. And the older generation doesn't accept that. The older generation thinks, okay, you're environmental guys, stupid guys, tell me what I should do, I will consider it maybe in my technical design. I made the boxes the same size because nowadays the environmental guys should be considered with the same importance than the technical, than we are. Normally, it is a technician who is the project leader and he should have a feeling for the environmental colleagues and not say, okay, out of interest what you're saying. Because we are getting stuck then at the ministry, because the ministry wants to have experts who are looking over our project, and if they say no, then it's a no. The best tunnel design has no chance if you do not consider the environmental guys. And it is a loop. I would say it's a loop. Okay, I say I need so many lorries a day on this road. The environmental guy says, no lorries on that way. For example, Brenner-based tunnel. We came with a lot of lorries per hour on the motorway. The population said, and the guys from the environment said, not one lorry will come on this road extra because there is already a lot of traffic. Okay, we went in a loop, and at the end, we decided we will build a third tube under the tube of the railway tracks, just for transporting the excavated material to a deposit. So we built kilometers of tunnels underground to bring all these materials by conveyor belts on the deposit area. We wouldn't have done that 50 years before, because we would have put it on a lorry and the lorry goes to the deposit area. This time is over. Nowadays, preparation works for tunnels who are bringing the material on conveyor belts, not on lorries, but on conveyor belts to the deposit area, have to be built first. And then, this is a preparation work, and then we can start with the tunnel. This is what we learned, and this is accepted by the environmental guys. It costs more, the project, but on the other side, it really fulfills the requirements from these guys from the environmental sector. The structure of our environmental impact studies in Europe is like that. Summary and overview of the measures. What do we do? Project justification and alternatives. And then we say, okay, we always start with tunnel operation. Why do we need this tunnel for the operation? Then, of course, a description of the construction phase. But the construction phase is limited. For example, the Brenner base tunnel will have a construction duration of about 15 years. So people who are living there, they know after 15 years we are gone, but then the operation starts. That's why the operation will run for the next 100 years or even longer. And then the question for the landfills. Where will we put the landfills and how can we reach these landfills? And of course, there are many factors. I just wrote 2 lines on it. Humans have to be considered. What is the influence to the humans because of this construction? What is the influence to the flora, to the fauna, and all those? There are many guidelines from the European Union to be followed nowadays, have to be done. And the environmental guys, by the way, they work in the same structured way than we as a tunnel engineer. We have our clear structure how we design this tunnel and how we go then from the design to the construction. It's very clear structured. But the environmental guys nowadays do the same. They say clearly, what is your impact on my environment? Is it a sensible area, yes or no? And what is the effect because of your construction? And then they sort out what is your relevance and they categorize you. And if you go down to the number 6 with your relevance of your project, you will have a really hard life. And then you come up and say, okay, I do this and that measures. Some countries do it in that way that they pay the environmental guys a certain amount of money and say, this is my measure, you get the money. This is not the way which we can go in future. The effectiveness of measures from very good to moderate, but there will be a rest of influence of the environment. There will be something which still is there, even if you do your best in, let's say, measures. And this is the essential result. What is the residual load on the environment because of your project? So you, for example, you have a tunnel, and after the tunnel you set some walls for noise protection for the houses who are behind. This is then a measure, but still the people living behind this wall will hear something. There will be a small rest of noise still which is there. You shouldn't come up with very high after all your measures which you set in your project. This is the way how the environmental guys are, let's say, working together with us. Because I was speaking about the excavated material, the point why we are not allowed to give it to the industry immediately is that the law says you are polluting your the mineral resources. Yes, the tunnel engineers are polluting the mineral resources a bit because they fill in plastics or they have other things which are brought to this mineral resource, but the point is the mining industry does the same. And we are checked by these ministries and the mining industry is not. If we would check the mining industry for the same parameters then we as tunnel engineers are checked, the problem would be that you cannot sell anything anymore because then it would come out that the mining industry also pollutes their material, so you buy a kind of waste. So we have to be on the same level. Either we are a waste or we are a product. But it must be the same than what the mining industry does. This is what we are, let's say, fighting for in Brussels. Okay, environmental indicators, I don't want to run through. I'm pretty sure you have the slides available. The global warming potential is always the one which is in the media, which is in the newspaper, but there are many others which have to be considered. And what we would like to see is that environmental impact studies have to consider all these factors, which can be clearly calculated. And when we are ending up there, then we will see that the construction industry will try to save resources on that way. So my summary is, supply the specific industry with mineral resources, such as steel, ceramics. I will come back to that a little bit later on in another talk. Find an economic optimum for the material management and the underground construction sites. Minimize the environmental pollution by an optimized material processing and transport. Reduce the CO2 production, but it is not only CO2, it's many more factors which have to be considered. Reduce the land use or landfill capacity for depositing excavation material. At the end, produce zero waste. This would be a wish for all the construction industry. That was my short introduction to this topic. Thanks for listening, and I'm open for questions. Thank you.